cloud computing has fundamentally changed the security architecture landscape. When your infrastructure runs on shared physical hardware managed by a third party, the security boundary is no longer a physical server room wall. Understanding cloud security is not optional for a CISSP.
Think of cloud security like renting an apartment. The building owner handles the structure, the plumbing, and the foundation. You handle what you do inside your unit. If you leave the entire front door unlocked, that is not the landlord's problem. The shared responsibility model defines that boundary precisely.
And the Capital One breach of 2019 is our case study. A misconfigured cloud web application firewall allowed an attacker to use a server-side request forgery attack to reach the EC2 metadata service and steal identity and access management credentials. One misconfiguration, over 100 million customer records exposed.
9 concepts covering deployment models, service models, shared responsibility, hypervisors, containers, cloud security tools, and the Capital One case study. Cloud security is heavily tested in the current CISSP exam. It is modern infrastructure, and the exam reflects that.
Stick around for the Capital One server-side request forgery case study later in this video. One misconfiguration, 106 million records. Starting with deployment models and why each has a different security profile. Let me introduce the team real quick.
Hey, I'm Michael. Honestly, I am hyped for this one.
Bella here. This one surprised me. I think it will surprise you too.
Hi, I'm River. I like connecting dots across different worlds. This is perfect for that.
All right, let us jump in.
Let us go through each model and the specific security concern the CISSP exam associates with each one.
The shared responsibility model is the foundational concept for cloud security on the CISSP exam. The key phrase, the cloud provider is responsible for security of the cloud. The customer is responsible for security in the cloud. This distinction is tested repeatedly.
The provider always owns the physical layer data center facilities, networking hardware, physical hosts, and the hypervisor that virtualizes resources. These are never the customer's responsibility, regardless of service model. The customer never patches the hypervisor.
The customer always owns their data and access management. Regardless of whether you use infrastructure as a service, platform as a service, or software as a service, your data is your responsibility to classify, protect, back up, and delete appropriately. Access management, who can access your cloud resources, is always your responsibility.
The middle layers shift with the service model. In infrastructure as a service, the customer owns and patches the OS. In platform as a service, the provider patches the OS. In software as a service, the provider handles everything down to the application. The exam will present vulnerability scenarios where you determine who was responsible.
Shared responsibility creates a dangerous false assumption. The customer assumes the provider secured something. The provider assumes the customer configured it correctly. This is the shared responsibility gap, the space where both parties assumed the other handled security, and the entire breach walks right through.
The Capital One breach is the most famous example of the shared responsibility gap. AWS provided a correctly functioning web application firewall service. Capital One misconfigured it. AWS was responsible for the web application firewall functioning correctly, and it did. Capital One was responsible for configuring it securely, and did not.
For the exam, River and Bella, the provider, secures the cloud infrastructure. The customer secures their configuration and data. When a misconfiguration is the attack vector, the responsibility falls on the customer. When the underlying infrastructure fails, the responsibility falls on the provider.
The hypervisor is the software layer that creates and manages virtual machines. It is the critical security boundary in virtualized environments. A compromise of the hypervisor means every virtual machine on that host is potentially compromised. The hypervisor sees all their memory and disk.
Type 1 hypervisors, called bare metal hypervisors, run directly on the physical hardware. There is no host operating system between the hypervisor and the hardware. VMware SCADA, Microsoft Hyper-V, and Xen are Type 1. The attack surface is smaller because there is no host OS to exploit.
Type 2 hypervisors run on top of a host operating system. VirtualBox and VMware Workstation are Type 2. The host OS adds a layer of attack surface. An attacker who compromises the host OS may be able to affect the hypervisor and all VMs running on it. Type 2 is used in development environments, not production cloud.
VM escape is the critical cloud attack. A vulnerability in the hypervisor or VM implementation allows code running inside a virtual machine to break out to the hypervisor level. From the hypervisor, the attacker has access to all VMs on the same host, including tenants in a public cloud environment. So if a Type 2 hypervisor's host OS is compromised, that is effectively the same as a VM escape. The attacker reaches the hypervisor level through the host OS, rather than through a VM exploit.
Not quite the same attack. VM escape exploits the hypervisor isolation boundary directly from inside a VM. The host OS compromise is a different attack path that gets to the same privileged position. Both are critical, but they are separate vulnerabilities.
VM sprawl is an administrative risk on top of that organizations spin up virtual machines and forget to decommission them. These orphaned VMs accumulate outdated, unpatched operating systems, each a potential attack entry point not in the official inventory. For the exam, Michael and Bella, Type 1 is bare metal, directly on hardware, smaller attack surface. Type 2 runs on host OS, larger attack surface. A VM escape is the attack that breaks containment. VM sprawl is the management failure that creates unpatched attack surface.
The hypervisor is the most privileged software in the entire virtualized environment, keeping it updated and minimizing its attack surface. Running no unnecessary services on the hypervisor host is the single most critical control in any cloud deployment.
Containers package an application and its dependencies into an isolated, portable unit. Unlike virtual machines, which each have their own OS kernel, containers share the host OS kernel, making them lighter and faster. The shared kernel is also the primary security concern.
Container isolation is implemented through Linux kernel namespaces and control groups, not hardware virtualization. This means the security boundary between containers is fundamentally weaker than the boundary between virtual machines. A kernel exploit could potentially break out of a container's namespace.
Container image scanning addresses supply chain risk. Container images are built from layers, often including third-party base images from public registries. Those base images may contain known vulnerabilities. Scanning images before deployment identifies vulnerabilities in the dependency chain before they reach production.
Kubernetes is the dominant container orchestration platform and has its own security model. Role-based access control controls who can manage which resources. Network policies define which pods communicate. Pod security standards restrict container privileges, and misconfigurations here are a common attack vector.
Container supply chain attacks are a growing threat. A compromised base image published to Docker Hub can be pulled by thousands of organizations. The SolarWinds-style attack applied to container images, malicious code baked into a trusted base image, is a realistic threat vector.
For the exam, containers share the host OS kernel, weaker isolation than VMs. Container breakout escapes to the host. Image scanning finds vulnerabilities before deployment. Kubernetes requires role-based access control and network policies. Supply chain attacks target base images.
Running containers as non-root and using read-only file systems where possible reduces the impact of container breakout. Defense in depth applies to containers just as it does to any other compute environment. Minimize what a breakout can accomplish.
The Capital One breach of 2019 exposed over 106 million customer records, one of the largest financial institution breaches in history. The attack path went through a single misconfiguration in an AWS web application firewall protecting Capital One's EC2 instances.
The attack technique was server-side request forgery. Server-side request forgery. The attacker sent a specially crafted request that caused the web application firewall to make a request to an internal URL on Capital One's behalf. The misconfiguration allowed that internal request to reach the EC2 metadata service.
The EC2 metadata service is an AWS feature available at a fixed IP address inside every EC2 instance. It provides instance configuration and, critically, temporary identity and access management credentials for the instance's assigned role. The attacker used the server-side request forgery to retrieve those identity and access management credentials.
With valid identity and access management credentials, the attacker had the same access as Capital One's EC2 instance role, which had been configured with broad S3 access. The attacker listed and downloaded hundreds of S3 buckets containing customer data. One misconfiguration opened a path to 106 million records.
The shared responsibility analysis. AWS provided a correctly functioning web application firewall service. The web application firewall itself was not compromised. Capital One was responsible for configuring it correctly, and the configuration was incorrect. The cloud provider fulfilled their responsibility. The customer did not.
The preventive controls that would have stopped this CSPM would have flagged the web application firewall misconfiguration. IMDSV2, the newer EC2 metadata service version, requires session-oriented authentication and would have prevented the server-side request forgery from reaching the metadata service. Least privilege identity and access management roles would have limited the blast at IUS.
For the exam, River and Bella, remember this one, Capital One illustrates that cloud security failures are most commonly misconfigurations, not provider infrastructure failures. CSPM, least privilege identity and access management, and server-side request forgery protection are the controls that would have mattered here.
Okay, it is quiz time. Let's find out what stuck. Think through each question carefully before you answer.
Hit like if the content is landing, and subscribe to stay locked in.
A company migrates to AWS infrastructure as a service and a vulnerability is discovered in the guest operating system running on an EC2 instance. Who is responsible for patching this vulnerability? The correct answer is C. The customer. In infrastructure as a service, the customer is responsible for managing and patching the guest operating system.
A penetration tester discovers a vulnerability in a Type 1 hypervisor that allows code running in one virtual machine to execute code at the hypervisor level. What type of attack is this? The correct answer is C. VM escape. Code breaks out of the virtual machine boundary to the hypervisor level, affecting all co-tenant VMs.
Which cloud security tool is specifically designed to detect misconfigurations in cloud infrastructure resources such as publicly accessible S3 buckets or overly permissive security groups? The correct answer is CISSP's Cloud Security Posture Management continuously monitors cloud configurations against security best practices.
Excellent work on the cloud security quiz. Here is what we built today. The Cloud Shared Responsibility Model provider secures the cloud, the hardware, hypervisor, and infrastructure. Customer secures the cloud, their data, configurations, and access management.
Service models determine the dividing line. Infrastructure as a service means the customer owns OS and above. Platform as a service means the customer owns app and data. Software as a service means the customer owns only data and access. The Capital One breach happened because the customer's configuration responsibility was not fulfilled.
Type 1 hypervisors run directly on hardware, smaller attack surface. VM escape breaks containment to the hypervisor. Containers share the host OS kernel, weaker isolation than VMs. Image scanning and pod security policies are the key container security controls.
Cloud Access Security Broker mediates user to cloud security. CWP protects workloads at runtime. CSPM detects misconfigurations. A CSPM tool would have caught the Capital One web application firewall misconfiguration before the attacker found it. Next is CISSP 3.9, Embedded Systems and Internet of Things. Watch that next video now.
Subscribe and keep the playlist rolling. Domain 3 is almost complete. One more content episode, and then the comprehensive review.
You have got this. Keep going.
Professor Erica signing off.